This is your note set on covalent bonds, looking at covalent molecules, naming them, looking at how the covalent bonds in general, if it's polar or nonpolar, and molecule polarity. This will be a few videos in terms of this note set, and this first set will just start with looking at the note sheet that you got handed out. So let's start with covalent bonds. We know that they are considered true molecules. Covalent bonds can also be called molecular bonds. When something is referred to as a molecule, it means that there is a covalent bond. So please make sure that you understand that this is an interchangeable word. Covalent molecules can also exist as a solid, liquid, or a gas. So they can exist as all three states of matter. Here are your rules for naming covalent bonds. We will practice this in class, but these are just some basic rules. So when we name covalents, we use prefixes such as mono, di, and tri. When we name ionics, we never use prefixes. So that's one of the biggest differences that you need to know. If the first element is monoatomic, we do not use the word mono. We do not use the prefix mono. So for example, CO2 is not monocarbon dioxide, it's simply carbon dioxide. If the first element has more than one atom, we do use the prefixes. The second element always needs prefixes regardless of the number present. So there are your rules, and we'll practice more of this in class. Here's some more basic notes on covalent molecules, and this is specifically referencing bond type. So covalent molecules share electron pairs equally or unequally between atoms. If electron pairs are shared equally, it's called a nonpolar covalent bond. We will reference the electronegativity periodic table, the bright yellow sheet, and be able to look at the electronegativity values for atoms. And if that value is from 0 to 0.3, we say that it is a nonpolar covalent bond. That nonpolar covalent bond means that those electrons are shared equally throughout the molecule. We represent that equal sharing with a double arrow, right like that, showing that electrons will hang out equally around both atoms. If electron pairs are shared unequally, it is called a polar bond. This uneven distribution of electron pairs creates a polar molecule, where there's a slight charge distribution difference. Unequal sharing results because of the electronegativity difference, causing the electron pairs to orbit around the more electronegative atom more often than around the least electronegative atom. Polar covalent bonds are going to be between 0.3 and 1.9 electronegativity differences, and we show that polar covalent bond by having an arrow pointing towards the more electronegative atom, and it's pointing in this case more towards chlorine, because chlorine is the more electronegative atom, and I will get further into how we identify that in the next video lesson. Bond length is just the average distance between two bonded atoms, and bond energy is just the energy required to break bonds, so the shorter the bond length, the harder it is to break. This relationship is inverse, so the longer the bond length, the lower the energy. The shorter the bond length, the greater the energy. So there's our bond types, and then there's our bond length and bond energy information. Now we're going to get on to molecule polarity. Molecules can be polar or nonpolar depending on the shape. So if a molecule is polar, we say that it looks different. I like to use the term or the phrase polar bears look different than other bears, and so when you have a polar molecule, we know that it looks different on all the sides. If you have a nonpolar molecule, it simply means that it looks the same on all the sides. So again, polar molecules do not look the same, and nonpolar molecules do look the same. With polar molecules, we will be able to tell the molecule polarity by building the structure, so we are going to do a lab where we will actually create these molecules, and we will also be able to figure it out by drawing the Lewis structure and the Lewis dot shape. And again, I will teach you that as well. So again, if you draw the Lewis structure of these molecules, we're going to see that they do not look the same if it is a nonpolar molecule, or if it is a polar molecule. If it's a nonpolar molecule, these look the same on all the sides. So that means that you've got atoms surrounding that look the same on all the sides. Polar bonds versus polar molecules. So to determine if a molecule is polar, first we've got to determine if there's polar bonds. If yes, you ask yourself if the poles cancel each other out. So if they do cancel each other out, the molecule is nonpolar. For example, CCl4 and CO2, those poles would cancel each other out. And you'll learn more about this and be able to see this when we do our models lab, because you will both draw these molecules and you will also build them to be able to see that these molecules do indeed have poles that cancel each other out. These molecules have polar bonds, but the poles cancel each other out, so the molecule itself is nonpolar. If they do not cancel each other out, we consider the molecule polar. So NH3, for example, if you kind of just think about how we would set that up, the nitrogen would be having 3 hydrogens around it. One of those sides is not going to look the same, so that's why we consider it a polar molecule. So this molecule will have lone pairs on the central atom, and that's a good rule to note because if a molecule has lone pairs on the central atom, we know that the molecule is going to be polar. If there are nonpolar bonds, there's no way that the molecule can be polar. So if there's nonpolar bonds, you're always going to have a nonpolar molecule. So there's your first set of notes. The next set of notes will start on this page right here.